Take 107. Welcome to the series Organic Chemistry for Biohackers. This is literally going to be a whole entire YouTube series giving you all the information about chemistry, organic chemistry, everything you need to know if you are seriously interested in elevating your brain health, life, performance, physique, fitness, all the chemistry you need to know if you're interested in having a really good freaking life. Today's video specifically is going to be about
acids, bases, salts, neutralization reactions.
I know my writing is a little crazy, but I promise this says neutralization.
Then we're talking about buffers,
Carbonic anhydrase, food science, and then we're just gonna go over some acid-base terminology and definition. The entire Organic Chemistry for Biohackers series also comes with a complete set of notes, and you're gonna be able to get these notes on my website, nutritionbyelsa.com. So go over there, get these notes right now, and use them to follow along in the video. What we are going to start with right now is just simple definitions of acid-base chemistry. An acid is any molecule that is capable of releasing free protons into solution. Here is a proton. Here's how we represent acids, HA. The H represents the proton, and the A represents some negatively charged molecule. Some examples of acids are things like HCl, which goes into a free proton and a chlorine molecule, HBr, which goes into a free proton and a bromine, or acetic acid. This is what's in vinegar.
CH3COOH.
And that goes into a free proton plus CH3COO minus.
So hydrochloric acid, hydrobromic acid, acetic acid.
These examples are also going to be found in the PDF notes document available on nutritionbyelsa.com. And a base is any molecule that is capable of absorbing free protons out of solution or releasing OH minus into solution. So bases are often represented as B plus or BOH. So this represents B plus can become HB. It gained a proton. Sorry, should be B minus. Yeah. And then H plus. Bases represented as B minus, and it is capable of gain. No, I got that wrong again. Here we go. Bases are represented as B. A base can absorb a positive proton out of solution, and then it becomes HB plus. Bases can also be represented as BOH, and it is capable of releasing this OH group into solution, and that is OH negative, a hydroxide ion, and then you're just left with the B, the base. So acids can release protons into solution, bases will absorb the free proton out of solution, or the base will be releasing a hydroxide ion into solution. Acids have a low pH and a high free proton concentration because acids release free protons. Bases will have a high pH but a low proton concentration. And this is exactly what the pH scale measures. The pH scale is an inverse logarithmic measurement of proton concentration. Literally all it means is that as pH decreases, proton concentration increases. The more protons you are able to release into solution, the more stronger of an acid you are. So strong acids will fully dissociate to release all of their protons into solution. Weak acids will only release some of their free protons into solution. So acetic acid, for example, what you have in vinegar or apple cider vinegar, that is a weak acid. And when you put acetic acid in solution, it does its acid dissociation reaction, but not to completion. It doesn't do this 100%. Strong acid, something like hydrochloric acid, in solution will fully dissociate and release its free proton into solution. And then you'll also just have the chlorine ion hanging out in there as well. So that's your introduction to acids and bases. I have a complete list of strong acids and strong bases here in the PDF notes available on nutritionscience.com. That was a very high level overview of what an acid is and what a base is, and let's just get into a few more definitions. So what is a salt? A salt is any ionic compound that is a positive ion plus a negative ion, and they are ionically bonded together. So they're held together by electrostatic interactions, and that is because one of them has a positive charge and the other has a negative charge. So they are able to bond together, and we call it a salt. Salts are things like NaCl, sodium chloride, MgCl, magnesium chloride, KCl, potassium chloride. You could maybe have NaBr, that would be
Sodium plus bromine, and that would make NaBr.
which is a salt.
NaCl.
This is sodium chloride. It's what you put in your food. It's table salt, or food processors will add this to food to enhance flavors.
Potassium chloride. Magnesium chloride. NaBr.
It's a salt. I've never heard of it, but if we're following the rules of what a salt is, positive ion, negative ion comes together to make a salt. So that is a salt. That leads us into neutralization reactions, and neutralization reactions are literally how we make salts. A neutralization reaction is an acid plus a base coming together to make one water molecule and one salt molecule. So the cool thing is that the neutralization reaction accomplishes two things. You're neutralizing the acid and the base. It's no longer acidic, it's no longer basic. And you're making, like you are literally making a water molecule, and you're making a salt. So I will show you what that looks like right now, because now I'm all excited about it. So neutralization reaction, let's make sodium chloride, because this is what we get in our diets, in our food, in processed food, packaged food, fast food, whatever. NaCl. NaOH is the base.
NaOH.
Here is your positive ion. Here is your OH, the hydroxide ion. NaOH plus an acid, because we are making sodium chloride, NaCl, we have to add hydrochloric acid. That is going to give us our chlorine. NaOH plus HCl. Here is your proton. Here is your negatively charged chlorine ion. When these two molecules react together, the base plus the acid, we make a salt
NaCl
plus a water molecule.
HOH.
Okay, water is 2 hydrogens, 1 oxygen, H2O. I like to represent it as HOH because it's more obvious that this came from this plus this, right? Here's your OH, here's your H. Of course, it's gonna make HOH. When this reaction happens, the H and the OH come together, and the Na and the Cl come together. And that is because the Na, sodium, carries a positive charge, and the Cl, chlorine, carries a negative charge. Likewise, the free proton here, well, we already said that a free proton is
H plus.
and this OH minus is a hydroxide ion.
OH minus.
Positive charge, negative charge, they are attracted to each other, so they come together, and when they come together, we have an H and an OH, which literally makes HOH, H2O, 2 hydrogens, 1 oxygen, that's water. Here is our neutralization reaction, and we have just made sodium chloride and water. So exciting! Let's do another one. If you guys are super into health and wellness, You're gonna love this one because I'm gonna show you now exactly the chemical reaction of making Epsom salt. So chemically speaking, Epsom salt is magnesium sulfate, and it is a salt. So it is formed in the neutralization reaction of magnesium hydroxide plus sulfuric acid. So when we're making Epsom salt, the stuff you put in your bath that's nice and relaxing, we are making magnesium sulfate. Magnesium hydroxide plus sulfuric acid.
H2SO4.
Here's your base because it's going to be releasing that OH minus. And here is your acid because it has an extra proton it can release into solution. We are going to be reacting the base and the acid together to make one salt and one water molecule. When magnesium hydroxide reacts with sulfuric acid, here is your hydroxide ion. Here is the free proton that sulfuric acid is going to release. The proton and the hydroxide ion come together and we get a water molecule. The magnesium and the SO4 minus sulfate, sulfide, SO4 minus, SO4 2 minus.
SO4 2 minus.
This reacts with the magnesium to make MgSO4. And then the hydroxide and the proton, those come together to give us water. Recall that salts are ionic compounds, so they are any compound that is a positive ion plus a negative ion, and salts are ionically bonded together. So MgSO4 is magnesium, Mg2 plus SO4 2 minus, Mg2 plus SO4 2 minus. This positive charge is attracted to this negative charge, and so these two ions will come together and make MgSO4. This is literally how you make Epsom salt. Epsom salt is MgSO4. It is made by the chemical reaction of magnesium hydroxide and sulfuric acid. Those two things react together to make Epsom salt and also a water molecule. Then you're gonna pop Epsom salt into your bath and have a nice, relaxing wellness moment bath. So that's so exciting. We covered acids, bases, salt neutralization reactions. This concludes, I actually ended up getting into food science. So food science, acid-based food, food processing, Clostridium botulinum toxin, that is going to be a separate video in acid-based chemistry in the series Organic Chemistry for Biohackers. Here's my behind the scenes, by the way. And yeah, this concludes the video, acid-based chemistry summary, basics, introductions. I hope you loved it because I had a lot of fun. Actually, it was a little stressful producing this video. I tried to make it yesterday, but I gave up. I didn't give up. I decided I'm gonna take a rest and I'm gonna do it again tomorrow, all fresh and re-energized. And so I don't even know what I'm talking about right now. This concludes the video. Goodbye, everybody. Have a good day.